students, now we'll start with the exercise 11.2, and remember students, the questions will ask in the examination most probably from this exercise. So as you can see in this construction, in this exercise we have to construct triangle, but here let's see that which parts of the triangles are given. So you can see in the question we have to construct ABC, where BC, that is one of the side, is given. We can consider BC as a base. Angle B is given, that is one of the base angle is given. Either B or angle C is given. It is not angle A, it's related with the base angle, we can say. As BC is given, so it must be angle B or angle C supposed to be given. And you can see this one, the sum of the other two sides are given. As base is BC, so the rest of the two sides AB and AC, the sum of these two is given 30. That doesn't mean that both are equal sides. So now let's see how we are going to construct this. So for the construction, first we'll construct the base, that is BC. We construct BC of 7 centimeter. As you can see, I required more space here, so I'll construct a line segment of 7 centimeter here. Let us give that name point B and point C. This is of 7 centimeter. Now the angle is given 75. As we discussed in the earlier videos that how to construct 75. Let us recall 75 is a bisector of 90 and 60 degree. So let's take any arbitrary radius from point B, as B, angle B we require. So from point B, we should construct the ray, an arc. From this point 60, from this point 120. Now from this point we should draw another arc, and from 60 degrees. So one from 60 and one from 120 we construct. So this is what the 90 degree we obtain. Let us draw the dotted, because 90 is not the main angle we require. So it should be a dotted line. We have to construct 75. So 75, as we discussed, it is a bisector of 60 as well as 90 degree. So this is angle 75 at point B we obtain. Let us draw, this is a ray. We can give this ray as BX. Now here the next is very important step. Now you can see that we obtain this too. That means we have B and C. Now the third vertex A is very important to obtain. Now how we are going to obtain is the most important part. You can see that here the sum of the other two sides are given 13. So what exactly we will do? We will take the length of radius 13 centimeter. 13 centimeter, 13. As you can see here, this is 13 centimeter, the length of radius I have taken. Now from this point B, we should draw an arc of that. Oh, you can see it comes very far. That comes very high, very high. So obviously I have to extend this. Let me extend this. And this is the intersecting point here, this one. Let us give that point E. Let me join EC. I will join EC now. Now still we did not obtain point A. Now to obtain point A, what we are going to do? Now we have to construct the bisector of this point. Now we learned that how to construct the bisector of any line segment, which we have already learned. So we should take the length of the radius more than half of EC. It is approximate measure, more than half. Then from one point C, we should draw an arc on this side, and with the same radius, one arc on this side. Now when you draw the perpendicular bisector, remember that once what the length you have taken should not be changed. keep the same radius, and from this point, that is from point E, we should draw the arc, and this both arc intersecting each other. This line segment which we construct, that line segment is called the perpendicular bisector of EC. Why it is called perpendicular bisector? Because this line segment must be 90, and you can see that here you can see that EC is just less than 30, so it must be half of it. So that is why it is called perpendicular bisector. Now the important, that where is point A? You can see this perpendicular bisector. If I'll give point M here, this is a bisecting this at a point M. The same way this ray, perpendicular bisector, intersecting this BE at this point, and I'll give that point A. So this is point A which we require. Let us join AC. So now this AC, when we join, you can see this triangle ABC is required triangle. Now how it becomes ABC is required triangle. So now let us justify and understand how it is required triangle ABC. So let us continue with the justification. So let us justify here. For the justification, you can see that this two triangle AME and AMC, that means triangle AME and triangle AMC, these both triangles are congruent. How it is congruent? Let's see. As AME is same as AMC because they both are right angles. EM is same as CM. As we discussed, M is the midpoint of EC. One more, that is AM, which is common side in both the triangles. That is common side. So you can see that by using side angle side, AME congruent, M congruent with M, E congruent with C, and A with A. By using side angle side, this both are equal. So as they both are equal, so we can say that AE is also same as AC by using CPCT. AE and AC both are same. Now let us learn the justification. As we are doing, it is a part. As at the beginning we construct BE is equals to 13 centimeter. This way, BE 13 we construct. So BE is basically AB plus AE. So AB plus AE as equals to 13 centimeter. But as we have just written, AE is equals to AC. So therefore we can say AB plus AC is equals to 13 centimeter. So this is the justification of triangle ABC. I hope students you understand this. It is a very important construction. Thank you.